separation confirmed. Dragon, separation confirmed. Stage 1 is transonic. Landing legs have deployed. And Falcon 9 has landed.
Hello everyone, it's Wednesday, January 3rd, 2024, and you're looking at a live view of our Falcon 9 rocket awaiting its 6:04 p.m. Eastern Time launch from Space Launch Complex 40 at Cape Canaveral Space Force Station in Florida. My name is Zachary Lupin, and I'm an avionics reliability engineer here at SpaceX, and I'm joining you from SpaceX headquarters in Hawthorne, California. Welcome to our live launch coverage of the Ovzon 3 mission for our customer Ovzon. Today's launch marks SpaceX's second mission of 2024 and 297th overall mission to date. Ovzon 3 is the first privately funded and developed Swedish geostationary satellite ever to be launched. It carries Ovzon's patented solution with high-power steerable beams and unique software-defined capabilities. It will become operational when reaching its exact destination and after in-orbit testing by mid-year 2024. We'll have more to share about tonight's mission later on in the webcast. At T-minus 10 minutes and 10 seconds, let's learn a bit more about the Falcon 9 supporting tonight's mission, which is flying for its 10th time today. Falcon 9 is a two-stage rocket that is designed and manufactured by SpaceX for the reliable and safe transport of people and payloads into Earth orbit and beyond. The entire vehicle stands at about 229 feet tall, or almost as tall as the Taj Mahal in India, which stands at 240 feet. The bottom two-thirds of the vehicle is the first stage, also referred to as the booster. Its objective is to accelerate the vehicle through the Earth's atmosphere to space using 9 Merlin 1D engines and then separate from the rest of the rocket. Not only is the first stage the largest part of the rocket, but it's also the portion of the rocket that we attempt to land on one of our autonomous drone ships or back on land for future reuse. Reusability is extremely important as it allows us to refly the most expensive parts of the rocket, which in turn drives down the cost of access to space. Located above the first stage is the second stage, which has a single Merlin vacuum or MVAC engine, which ignites after the first stage separates. And that second stage is what will carry the Ovzon 3 payload into orbit. The payload for tonight's launch is safely enclosed inside of the 17-foot diameter payload fairing, which is that large barrel structure with the pointed nose on top of the second stage. Manufactured out of carbon composite, the fairing protects satellites on their way to orbit and get jettisoned approximately 3 minutes into flight. The fairing halves supporting tonight's mission are both flight-proven, with one half flying for its 9th time and the other half flying for its 14th time. After separation from the second stage, both fairing halves will return to Earth and be recovered by our recovery team. At T-minus 8 minutes and 20 seconds, Falcon 9 is tracking no issues and the payload is healthy. Propellant loading started at the T-minus 35-minute mark and will finish at around T-minus 2 minutes. Weather is currently green and the range is ready to support tonight's mission. However, if for some reason we do not launch tonight, we do have a backup opportunity tomorrow with an 87-minute launch window opening at 4:47 p.m. Eastern. For now, let's learn a bit more about tonight's mission and the payload on board our Falcon 9.
Ovzon is a world-leading mobile satellite communications services company offering integrated SATCOM as a service to customers across the globe. Ovzon was founded in Sweden in 2006. At that time, the company was focused on designing, developing, and delivering the most capable mobile satellite terminals. With mobility, we really mean the smallest, easiest to carry, lightest and best performing satellite terminals. Today, Ovzon is the leading solutions provider of fully integrated end-to-end SATCOM as a service that delivers the highest levels of connectivity. We have customers and end users in the US, in Europe, and other parts of the world. Since 2018, the company has invested heavily in major technology development programs. The most prominent technology platforms are Ovzon 3, the integrated Ovzon onboard processor, and the smallest mobile terminal, Ovzon T7. What sets us apart from any other competing satellite communication provider is that we manage and control the entire service value chain. We deliver Satcom as a service with immediate connectivity. Our commitment to customer support is second to none. We deliver 24/7, 365 customer service and support in both a centralized and decentralized way. Satellite communications has today become an integral part of the broader communications landscape that connects and powers the world. The increased geopolitical tensions in the world fills our news daily. The warnings of environmental changes are obvious, as we see growing numbers of natural disasters such as floodings, storms, and wildfires. This has also led to the increased refugee streams across borders. For our customers, this harsh truth has become more and more obvious. Fast, easy to use, and guaranteed satellite communication solutions are critical. Ovzon operates in the premium segment with customers and markets with no fail requirements and a demand on guaranteed performance, resiliency, and mobility. Ovzon is well positioned in this market. At Ovzon, we're confident about our ability to deliver and meet the world's rapidly increasing need for high-performing, resilient, and fast mobile connectivity via satellite.
Coming up shortly, the transporter erector, or TE, will retract away from the Falcon vehicle. The TE is that large truss structure you see there next to the rocket. First, we'll see the clamps open around the second stage, and then the TE will begin to pull away from the rocket slightly. At T0, ground hydraulic systems will pull the TE even further away from Falcon 9 as it lifts off. We should be seeing those clamp arms opening in just a few moments. And there you can see those clamp arms opening around the second stage. The first stage is connected to a launch mount at the base of the TE, but the structure is hinged and will retract away from the vehicle in preparation for launch. You may also hear it referred to as the strongback from the launch team. We use the TE to roll the rocket out to the pad and raise it to its vertical launch position. The TE also routes the vehicle's fluids, power, and telemetry umbilicals from the ground systems to the rocket and payload until Falcon 9 goes on internal power and clears the pad. At this point in the countdown, both the first and second stages are nearly fully loaded with 1 million pounds of kerosene fuel and liquid oxygen. Both the first stage and second stage should finish loading propellant about a minute apart from each other, with the first stage finishing up at the T-3 minute mark and the second stage at around the T-2 minute mark. You may have also noticed those white clouds around the rocket. They are part of the chilled gas above the LOX tank liquid surface that we vent overboard to maintain pressure in the tank as needed. And when that gas comes out into the Florida air, the humid, moist air condenses into clouds and water. At T-minus 60 seconds, Falcon 9 will be in startup.
Stage 1 LOX load is complete.
And there you heard that call out that Stage 1 LOX loading is complete on the vehicle. At T-minus 60 seconds, Falcon 9 will be in startup. This means that the rocket's autonomous internal flight computers will have taken over the launch countdown. And then just inside of T-minus 2 seconds, we'll light the Merlin 1D engines for liftoff. The Ovzon 3 payload continues to be healthy, and the Falcon 9 team is tracking no issues on the rocket. Now, it's worth noting, at the request of our customer, we will not be sharing any views of the payload today, and will be ending the webcast with the Stage 1 landing. Weather is still looking green, and the range is ready to support our T0 of 6:04 p.m. Eastern Time. And with that, we're proceeding into the last few minutes of terminal count. Coming up in just a few moments.
Stage 2 LOX load is complete.
And there's that call out that Stage 2 LOX loading is complete on the vehicle. Falcon 9 is now fully loaded with 1 million pounds of kerosene fuel and liquid oxygen. At the T-minus 1 minute mark, Falcon 9 will be in startup, and this is when the rocket's flight computer will take over the launch count.
Falcon 9 is in startup.
And there you heard that call out that Falcon 9 is in startup. Next, we wait for the go for launch from the launch director.
LD, go for launch.
And there you heard that the LD is go for launch. So at T-minus 38 seconds, all systems are go for launch of Falcon 9 with the Ovzon 3 payload.
T-minus 15 seconds to count. T-minus 5, 4, 3, 2, 1, 0. Mission liftoff.
Vehicle pitching down range. M1D chamber pressure is nominal.
At T plus 30 seconds and counting, Falcon 9 has successfully lifted off from Pad 40 at Cape Canaveral Space Force Station, carrying the Ovzon 3 payload. Now, during the rocket's ascent, we'll tilt the engines, the technical term for that being gimbling, and that's when we turn the rocket horizontally in what
Power and telemetry is nominal.
in what we call a gravity turn. The rocket will still be going up, but will now also be headed horizontally away from the launch pad. Moments ago, we also throttled the engines down in
Falcon 9 is supersonic.
for max Q or maximum aerodynamic pressure.
Max Q.
And there's that call out for max Q, and this is when the vehicle experiences the greatest amount of aerodynamic stress as it ascends through the Earth's atmosphere. The rocket typically needs to go about 17,500 miles per hour horizontally in order to avoid being pulled back down to Earth and get into orbit. As the vehicle continues to ascend, make sure to watch that telemetry at the bottom left-hand corner of your screen. Coming up shortly, we're going to have 5 events in rapid succession, starting with MECO, or main engine cutoff. This will be followed by stage separation. Then we'll have the stage 1 flip. This will be followed by the second engine start 1. And then lastly, we'll have the boost back burn startup on the Falcon 9 first stage. And the sequence of events should start in about 10 seconds from now.
MECO. Stage separation confirmed. MVAC ignition.
Stage 1 boost back startup.
And there you heard and saw those events happening back to back with MECO, followed by stage separation, stage 1 flip, followed by the second engine start 1, and then the stage 1 boost back startup. Coming up shortly will be fairing separation. This is when we jettison the fairing halves away from the second stage. And as I mentioned earlier, both fairings are already flight proven, and we'll be attempting to retrieve these fairing halves again once they fall back to Earth.
Fairing separation confirmed.
And there's that call out for fairing separation. In just a few moments, we should see the boost back burn end on the Falcon 9 first stage.
Stage 1 boost back shutdown.
And there's a confirmation of boost back shutdown on the Falcon 9 first stage. It's T plus 3 minutes and 40 seconds into tonight's mission. Now, just past the T plus 6 minute mark, you should see on your screen the Falcon 9 first stage's entry burn. To start the entry burn, we'll relight 3 of the Merlin 1D engines, starting with the center engine known as E9, and this will be followed shortly after by the E1 and E5 engines, which slow down the vehicle as it passes back into the Earth's atmosphere. We need to slow down to reduce re-entry forces, which then helps us recover and reuse the first stage. During the entry burn, Falcon 9 is decelerating by firing its Merlin engines, but it's still moving incredibly fast, and this causes the vehicle to fly through Merlin's exhaust gases, also known as the rocket's plume, and this deposits a layer of soot on the vehicle's surface. That soot comes from the carbon-based fuel that Falcon 9 uses, and with each flight, the soot builds up a little more on the outside of the vehicle. Now, given that tonight's mission is this booster's 10th overall, that soot layer is noticeably visible on the skin of the booster. On the left-hand side of your screen, we've got live views from our Falcon 9 first stage, and on the right side is a ground tracking shot of that booster as it descends back to Earth. And as I mentioned earlier, you can see the speed of that rocket with the telemetry shown at the bottom left-hand corner of your screen. As I discussed earlier, reusability is key to lowering the cost of spaceflight, which enables more investments in critical scientific research. The Falcon 9 first stage that is supporting tonight's mission will perform this entry burn for the 10th time, and that entry burn should start in about 25 seconds from now.
Stage 1 entry burn startup.
And there's that confirmation of startup of the entry burn on our Falcon 9 first stage. As a reminder, on the left-hand side of your screen is a view from the booster live, and the right side shows a ground tracking shot of the booster.
Stage 1 entry burn shutdown.
Stage 1 FTS is safed.
And there's confirmation of entry burn shutdown on the first stage. Now, the Merlins on the first stage are optimized for sea level, and these achieve 190,000 pounds of thrust each during ascent and descent. At liftoff, Falcon 9's first stage has thrust greater than 5 747 airplanes at full power.
Nominal trajectory.
And is consuming approximately 700 gallons of fuel per second. We also just heard that call out of nominal trajectory. Coming up in just about 10 seconds, we should see the landing burn start on our Falcon 9 first stage.
Stage 1 is transonic.
Second stage in terminal guidance.
Stage 1 landing burn.
And there's confirmation of the stage 1 landing burn.
Stage 2 FTS is saved. MVAC shutdown.
Landing leg deploy. Stage 1 landing confirmed.
And there you have it. This landing marks SpaceX's 261st recovery of an orbital-class rocket, including first-stage landings for Falcon 9 and Falcon Heavy. And as a reminder, we'll be ending the webcast here at the request of our customer. We also just heard confirmation of nominal parking orbit. All of us here at SpaceX want to thank our customer Ovzon 3 for entrusting us with tonight's mission. We also want to give a shout out to the Range and Federal Aviation Administration for supporting tonight's efforts. That'll conclude our webcast coverage of SpaceX's second launch of 2024 and 297th overall mission to date. Thanks for tuning in, and we'll see you again very soon.